Alrighty, so let's take a look now at the perfect square trinomials. And here's the formula for that. What you realize is that the first item and the last item are something squared, and you can multiply those two together to give you the 2. And this is basically the product formula that we learned backwards, is all of this is. So what I mean by that is, I'm sitting here and I'm staring at the formula and I go, hey, that's something squared. Can I rewrite 36 as something squared? Well, I can, right? That's a 6. Then the next thing I need to keep in mind is, okay, well, that's an x, that's a 6, that's a, right? That's a, that's b. So I get a 6x in the center, but does that 2 give me 12? 6 times 2, well, it does. It gives me 12. So in those circumstances, since the first and the last term are something squared, and when you take those two terms and multiply them by 2, I get the center term, then I know that I can just simply rewrite that as x plus 6 squared.
Holy hole in a donut!
So more perfect square trinomials, it also works with subtraction is basically what this means. That's a minus b squared. So once again, when you want to see if you can speed up the factoring process with these, I would look at the last term and say to myself, is that something squared? Well, it is, right? It's 4. So far so good. Then I look there and say, can I take the 4 and the x, which is 4x, and can I multiply it by a negative 2 to give me that center term? Well, 4x times a negative 2 actually will give me a negative 8x. And since that happens to work, and it's subtraction, that's why we end up getting the x minus 4 squared as our factors. So it's just to speed up the process. If you don't remember it, you can sit there and say what multiplies to give you 16 that also adds to give you negative 8. And you know what? Negative 4 and negative 4 work. So either way, you can still get the answer. So when I sit here and look at this, I see example 3, and I go, well, can I rewrite the first term as something squared? Yeah, I can, right? Because what is 4? How can you rewrite 4 as something squared? Well, I can rewrite that as 2, right? 2 squared. So that's 2 squared. That's an x squared. And the 25, I can rewrite as something squared as well. That's 5 squared. So what I actually have here is a 2 squared, an x squared, and a 5 squared. Well, I can group these together. Because they're both squareds, I can group them together as a 2x squared minus a 5 squared. According to our difference of squares formula, all that means is I take the first item and the second item, and I add them together, and I subtract them together. So 2x plus 5 and 2x minus 5, and there are my factors. This next one is, I have to look to see if I can square the first and last term again. Well, I can, right? 9 I can square. That becomes a 3 squared. And I have a y squared. The last term is 16. I can rewrite that as a 4 squared. So according to my rule that I said, you take these terms, which happens to be a 3y and a 4, and I get a 12y. Can I multiply that by a 2 to get 24y? Well, 3y times 4 is 12y. 12y times 2 is, well, that is 24. So it works. So because it works, what that means, according to the formulas, is that I can take the first term, which is a 3y, I can take the last term, which is a 4, and combine them together and just square it. And once again, if you couldn't remember that, you could factor that by doing slide and divide, which we will talk about soon, or by factoring by grouping, by sliding it over and seeing what multiplies to give you that incredibly large number, which I guess what is 144, that also adds together to give you 12. Or 24, and it happens to be 12 and 12, so you could separate it and try to solve it that way if you wanted.
Holy mashed potatoes.
Looking at this one, can you rewrite the first and the last term as something squared? Well, 49 you can, right? 7 squared gives you 49. And 1, can you rewrite 1 as something squared? Well, most people forget this, but yeah, you can. You can rewrite 1 as something squared as 1 squared. So you have a 7r squared, and you have a 1 squared. So when you multiply a 7 and a 1, you get 7. Can you multiply that by a negative 2 to give you negative 14? Yeah, 7 times negative 2 is negative 14. That's what we have right here, which means it's one of our factoring formulas. So I combine the first, which is 7r, and the last, which is 1, and because this is subtraction, it's a 7r minus 1 squared. And once again, if you wanted to, you could have grouped that together to see what gives you 49. That also adds together to give you negative 14. That would happen to be negative 7 and negative 7. And you could factor by grouping, or what we will eventually talk about, slide and divide. You could try that out as well. And once again, this is just me showing you could factor it. What multiplies to give you 49, that adds to give you negative 14. That's negative 7 and negative 7. And then you could factor by grouping, which is what we just talked about. I could take a 7 out of this, and I could take an r out of it to leave me with 7r and 7r minus 1. And I could take a negative 1 out of both of these. And the reason I take a negative 1 out is because I want it to look like this factor. So you end up with a 7r minus 1 and a 7r minus 1, which is 7r minus 1 squared. So just something to keep in mind. And when we come back here, we will factor some more polynomials.